Hello, good morning. Okay, so today we are going to learn about Module 3.1, which is classifying rational numbers, and Module 3.2, which is finding the opposites and absolute value of rational numbers. So once we learn what a rational number is, it's pretty easy squeeze because we should already know what an opposite and absolute value is from Module 1. So the first thing we're going to talk about is what is some terminology here. First, we need to know that a whole number includes those counting numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, et cetera, and they're always going to be positive. Okay, so whole numbers are kind of the most exclusive group of numbers. They have to be positive, they have to be whole in order to be considered whole numbers. In Module 1, we learned about integers. Integers are all of the whole numbers and their opposites. So whole numbers, 0, 1, 2, 3, 4, 5, 6, blah, 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 are all considered integers as well as whole numbers. But then the opposite, the negative version, so the opposite of 5 is negative 5. This negative 5 is only an integer because it is negative. So because it's negative, it's not a whole number, but it is a whole, it's an opposite of a whole number, so it's an integer. Finally, we're going to talk about rational numbers. Rational numbers are all numbers that can be written as a fraction, a over b, where a and b are integers and b is not 0. So all numbers that can be written as a over b would be things like a regular fraction, right? 3/4, this is a rational number, a over b, you have a numerator and a denominator. We have like decimals, like 0.25 or 25 hundredths can be written as a fraction, as well as whole numbers, like 3, we know we can write this as a fraction by putting it over 1, and all of our integers can be written as a fraction by putting them over 1. So what this means is that whole numbers are integers, and they are also rational numbers. And integers are integers and rational numbers. But then there are some rational numbers that are simply just rational numbers. So we're going to look at this a little bit closer in a second here. These are some conversions that we need to have memorized. So if you don't already have these written down somewhere in your notes, I would put these down now, pause the video and write them down. And what these are just some conversions that you're going to see every day. Not technically every day, but these are the most common. So we use half, fourth, 3/4, fifths, 2/3, these types of things when we're measuring, when we're cooking. So these are just some good ideas to have written down. So what we're going to talk about next are whole numbers, integers, and rational numbers and how they compare to each other. So I like to draw this where whole numbers are this inner circle. These are your 0, 2, 4, 7. Your whole numbers kind of live in this circle. Then there's a second circle, and in this second circle, we have integers. Okay, integers would be all of your opposites, -3, -13, -247, -1215. These are all integers. Now, your whole numbers is like, let's say 4 here. Oops, I want my arrow, not my. 4 can travel outside into the integer realm, okay? Because integers are all of the whole numbers and their opposites, but integers can't go inside the whole number realm. And then we have one more on this very outside here, which is rational numbers. So rational numbers are anything that can be written as a fraction. These would be your repeating decimals. These would be your regular fractions. They'd also be like your mixed numbers or your improper fractions as well. So it's important to remember here, and I like to kind of think about it as a club. So every number is allowed in the rational number realm, okay? Every single one. Doesn't matter who they are. They're allowed to be out here in this, they're dancing, everyone's having a good time. Now, this integer, it would be like your VIP lounge where people can get in there and they get that apple juice. So integers, while they can hang out here, can also come in here. So whole numbers could also come in here as well. However, like this half number, because it's not a whole number, cannot move inside. So this stays on the outside. And then whole numbers can move in the inside here into this very, very important person lounge. So 5 is a whole number. It can hang out here in the integer realm, and it can also hang out in the rational number realm. So all numbers are rational numbers that we're going to talk about in 6th grade, okay? Some of the rational numbers we talk about are considered integers, and some of those integers we talk about are considered whole numbers, and that's kind of what we're going to look at in our homework. Now, when we look at a number line, it's important to remember that when we are graphing a number, we're still talking about that number's distance from 0. So if I was talking about 1/2, or the same would be 0.5, it is half of a step from 0. So if I was going to graph its opposite, I would need to go half of a step away from 0 on the other side. Okay? This is important when we look at numbers like, let's say, negative 2.34. If this was my number line, this is 0, 1, 2, a little further here, 3. I know that this is 2 full hops away from 0, 1, 2, and then it's a little bit more of a hop to actually make it to negative 2.34. So it's important to realize that any of this, or if we're looking at a mixed number, this would be 1 full hop away from 0 and then 3/4 of another hop. So we have to do those whole number hops first. So when we're talking about opposites, we know that we're going in the opposite direction. So because I did 2 and a little bit of hops here, I need to do 1, 2, and a little bit of hops here. So my opposite would be 2.34. Move my face here. Okay, so the same with negative 1 and 3/4. We did 1 full hop and then 3/4 of another hop. So my opposite would be 1 and 3/4. Now, absolute value, remember, is distance from 0. So because negative 1.27 would be 1 full hop and then 27/100ths of another hop, our absolute value would be positive. And then 7/8 would be 7/8 of a hop away. So my absolute value would be 7/8. Now, your homework, nope, that's not it, would be on page 51 and 52, 8, 9, and 10, 14, 15, 16, and 18, and then 8, 10, 12, 14, 19, 20, and 23. If you need more help or extra practice, please make sure that you get on Khan Academy. Good luck.